Hey YouTube, what's up? Dr. T here in St. Petersburg, Florida. As a means to feature other topics that interest me, I am pleased to announce a new subject I will just call specials. And here, part 1 of 3 is about NASA's James Webb telescope, due to be launched sometime in 2019.
We tried some things that many people said was impossible, but we've achieved that, and we wish Hubble the very best.
The Hubble Space Telescope achieved its greatest performance yet, looking for when and how the universe began.
With the Hubble, we made incredible discoveries. We measured the age of the universe. The discovery of dark energy was actually confirmed by Hubble. People argued about whether black holes were in the center of the galaxies. We found black holes everywhere. It told us amazing things. But as we look deeper and deeper and deeper with the Hubble Space Telescope, we come to the end of what the Hubble can see. We just see darkness. We realized we should build the largest space telescope humanity has ever conceived of. This is the next generation space telescope. It's Hubble 2.0. And we have 1,000 people working on this project right now. And that all comes together on the launch pad in 2018. If it works, it's going to see deeper into space than any other telescope in history.
The Webb telescope is 100 times more powerful than Hubble. Telescopes keep getting bigger because the bigger they are, the more light they can collect, and the better the resolution. You know, at some point you build a telescope that's too big to fit in a rocket. James Webb would not fit in a rocket. So we had to make the primary mirror into individual segments. Learning how to build a segmented telescope, this is new. It's been done on the ground once or twice, but doing it in space is a whole nother set of challenges because the mirrors have to be lightweight. You have to figure out how to align the mirrors in space. You know, we wouldn't have built a telescope this big unless we needed to, and you need to build a telescope this big if you want to look at the very dimmest, most earliest galaxies in the universe.
If you took one of the mirrors and you spread it out the size of the United States, there would be no hill or valley that's larger than 3 inches, to give you some idea of just how perfect these surfaces need to be.
These mirrors are going to literally watch the universe light up after the Big Bang. They will help us learn about the beginnings of galaxies, the beginnings of stars, and exoplanets, planets orbiting other stars. These mirrors are going to capture the very first light of the universe.
Observation is everything. Ultimately, science is about observation. It's like Galileo when he lifted his telescope to the stars for the very first time. There's no turning back from that moment. He looks at the moon, and this was supposed to be this perfect orb It had rocks and craters and was far from perfect. And then he looked at Venus. It had crescents that changed as they moved across the sky. He looked at Jupiter, and he noticed these pinpricks of light. And as he watched them over the weeks and the months, and realized these weren't stars, these were actually moons in orbit around Jupiter. And of course, he realized that Ptolemy was wrong, Copernicus was right. We were no longer the center of our solar system, the sun was. The church could no longer argue that everything had to be centered around the earth. Observation trumped ancient wisdom. And that's what science does. It makes irreversible changes in our worldview.
At the beginning, when I first came on to work on JWST, wasn't terribly straightforward for me to keep track of which orientation was what. Okay, which direction was J3 and J2 and J1 again? You would sit in a conference room with people and they would grab like a stapler, you know, and go, okay, this is the spacecraft, you know, and then here's my instrument, and then this, and it just seemed a little silly. Which way's it pointing? And so I brought in my Lego set one day and went, build it. Let's build it.
I think everybody wants to do something, be a part of something greater than just what they can do alone. Building something like JWST is that. So what I don't understand is why everybody isn't trying to do it. Trying to be, you know, an engineer, work on these big projects, becoming scientists, you know. I mean, I don't know, what else would you want to do with your life?
Hubble Deep Field was a pure discovery. It was, we don't know what's there, let's see if we can see something. The second director of the Hubble Space Telescope said, you know, Hubble is looking deeper and deeper in the universe. I wonder what happens if we just stared at a completely blank piece of sky and just see what we find. And so he decided to point the telescope at a single blank piece of the sky, no bigger than a drinking straw. That's the area of the sky he decided to look at with the Hubble Space Telescope, and just stare at that single blank spot for 10 days and see what would happen. A lot of people said he was crazy, he was wasting telescope time, but the telescope was orientated and just stared at that one spot for 10 days with our most sensitive cameras at the time. And to everybody's surprise, when they looked at the image, out of that dark area of the sky came 10,000 galaxies in that single point of sky. Nobody had any idea there was this many galaxies in the observable universe. When you look at the Hubble Deep Field, only 3 of those points of light are stars. Every other point of light in that image is a galaxy. So there are 10,000 galaxies in every spot of the sky the size of a drinking straw. Roughly 100 billion stars in the galaxy. If you do the math across the whole sky, it's 10 to the 22 stars in the observable galaxies. And I'm not going to work out what that is, but it's 10 with 22 zeros. It's larger than even the US debt, you know. That Hubble Deep image is what inspired the James Webb Space Telescope originally.
Stop.
Slow down, slow down. Slow.
When people think about the telescope, they think of the huge mirror, right? That's the iconic part of the telescope. But this is what the astronomers care about. This is where the data comes from, the detectors and the cameras. All the images and the spectra, all the good stuff. It'll come from there. You know, it's $1 billion worth of hardware in there.
So this is the first time you're going to go cryo-test the 4 instruments all together, put together in one place, and the IEC, which is your instrument electronics compartment, all of it's together. This is the Space Environmental Simulator, and so they're putting it in for thermal vacuum testing. Launch is not the greatest stress for this telescope. It's actually going to the cryogenic temperatures. The temperature we're going to is 40 Kelvin. 0 Kelvin is absolute zero.
What happens at absolute zero?
Oh, the universe stops. All the physics changes at cryogenic. Things that expand, contract, things that contract, expand, for instance. So you don't know how these things are going to do till you get there.
Well, it's roughly room temperature out here. It's just like space on the other side of that wall. What would happen to a human being in this cryogenic?
Oh, they die. You would blow up as the pressure goes down, so you'd explode. If you survive that, then when the nitrogen goes in, well, you die of asphyxiation.
Fundamentally, the telescope is a time machine. The telescope is always a time machine because your eye is a time machine. You can see things as they were when they sent light to you. It takes 2.5 seconds for light to go from here to the moon and back. You see the sun as it was 500 seconds ago. About 8 minutes. We're 6 feet apart, so you're seeing me 6 nanoseconds as I was 6 nanoseconds before you see me. So light travels at the speed of 1 foot per nanosecond in round numbers. You see the Andromeda Nebula as it was about 3 million years ago, and that's about as far as you can see without a telescope. But with a telescope, you can see billions and billions of light years out in space, so billions and billions of years back in time.
So I hope you're enjoying this as much as I am. Come back for part 2 and I'll see you in a short time.